So what we'll do today, last week, Thursday, we would have finished off chapter 9.2, algorithm design. The different parts of the algorithm, what the algorithm is, what you have to do to design your algorithm. So do your homework for next week. Next week we shall look at it. So this week, what we'll be looking at is 9.3 Pseudocode. And so last week we would have looked at what is the algorithm. And if you guys can remember, when it comes to programming, in the first chapter, there is basically the identifying the problem stage, then creating your algorithm. That's what we looked at last week. And in the algorithm, we would have looked at that the pseudocode and the flowcharts are types or kinds of the algorithm. So the pseudocode is what we'll be looking at today. When we finish with this, then we'll look at flowcharts, which is the next kind of algorithm. So to get us started, let's have Arlton. Can you read for us pseudocode?
Pardon, sir?
Can you read the paragraph pseudocode?
Okay. Can you read it properly?
Yes.
Pseudocode is not programming code, but use English type words and phrases that are clear enough to be easily converted into programming code. It uses the same statement, keywords, variables, conditional statements, and loops described in the previous section to create the instruction for the solution to the programming problem. Pseudocode can also be developed from an Ipo chart to specify what data is input and processed into the information. Let's review the Ipo chart to find some of three numbers.
Alright, let me see up to where you should read. Okay, read out till to the bottom. Continue at note.
Oh. Note the variables number 1, number 2, and number 3 will store the first, second, and third numbers that are input. The processing column involves short statement explaining how the data is managed. Here, the values that were input into the variable numbers, number 1, number 2, and number 3, are added. The third column indicates that the result of the addition is output. The name of the segment to the code is added 3 numbers. The keyword input and output are used to indicate data is input, usually using an input device such as keyboard, while output can be a soft copy to the screen of the monitor. The keyword end or stop denotes the end of the statement. The pseudocode in example 5 is produced for the Ipo chart.
Good, thank you. So, as is mentioned, the pseudocode is not a programming code. So, When we are implementing our program, then we convert it over into a programming code, such as Pascal, VBA, whatever the case may be. But pseudocode is not a programming code. It is English words and phrases that we convert into the programming code. So basically, they tell us the instructions, because remember, this is the algorithm. The algorithm is a step-by-step, precise steps or instructions that you follow to carry out the program or the instructions. So your pseudocode now is in English words, and we use them to convert them into our program. Now it uses the same statements, keywords, variables, conditional statements, and so on that was described before. And we can create our pseudocode from the Ipo chart. So those of you who remember, this here is our Ipo chart. Doesn't look like a chart. It's actually like a table. And it has 3 columns, and it has the 3 parts of how the data is being processed. We have the input part, we have the processing, and then we have the output. For this now, we can create a pseudocode basically saying exactly what will happen. So our pseudocode could have been something like accept as input number 1, accept as input number 2, accept as input number 3. Then under processing, we could say add the 3 numbers together, and then in the output of our pseudocode, we can say produce the results of the addition that we would have processed before. So we basically put it as simple words that we can understand. So when we are creating our program now, we know what is happening at each step. So in this example here, note that the variables number 1, number 2, and number 3, they're going to store the numbers as they are inputted. Remember, variables are basically containers. So imagine like a bowl. They're containers that hold the value that are inputted. So number 1 is the name for the first variable or the first bowl. Number 2, number 3, those are the names for the second and third bowl. So those are what will hold your numbers as they're inputted. Now the processing column involves short statements explaining how the data is managed, how the data is going to be added, and the third column is the output. If you want the output to be printed, if you want the output to be soft copy, which means it's on the screen, however you want the output to be. Now, the name of the segment of pseudocode is and 3 numbers. So the keywords input and output are used to indicate that data is input, usually using an input device. So you can say for that part of the pseudocode, input number by pressing a key on the keyboard, or input number by voice, so the person can speak the number. Whatever the case, it depends on what program you are creating, for what purpose, and how they will be making that input. So you can specify now how that will be. How do you want the output? Are you going to state that the output is going to be soft copy on the screen, or something that is printed? And notice we always have to tell the program when to end. So we can put keywords such as end or stop, so that the program knows that, look, I shouldn't continue anymore, and that is where I should end. So we're going to look at example 5 now. Avish, Did you read for us? You can start from the pink box.
Sir, start from where?
The box. Pseudocode.
Pseudocode 5A. Add three numbers. Input number 1, input number 2, input number 3. Add number 1 plus number 2 plus number 3. Output result of number 1 plus number 2 plus number 3. Add end of pseudocode. If If the three variables that contain the three numbers have the same data type, for example, an integer, then the statements to input the values can be placed on one line as shown in the updated pseudocode below. Pseudocode 5b. Add three numbers. Input number 1, number 2, number 3. Add number 1 plus number 2 plus number 3. Output result of number 1 plus number 2 plus number 3. End of pseudocode.
Alright, give me a second. Let me look at these two boxes. So let's see what is the difference here. So notice how they put the input. In the first example, they have it in 5a, pseudocode 5a, they have it in different lines, maybe to indicate that if the numbers have different types, remember we looked at our data types, they're different data types. They're integers, real, characters, and so on. Remember we're doing numbers. So for numbers, there's two kinds of numbers. They're integers, which are whole numbers, and real numbers, which are fractions. So in this first example here, we can separate it, like this case here, if we know we'll be accepting different data type. But in this case at the bottom here, what they're saying is that if we know it's going to be the same data type, if we know all of the numbers that we are accepting is going to be, for example, integer, then we can place them in the same line of that pseudocode because they're going to be the same kind of data. Continue, Avish.
Now that we are familiar with variables, we can also place the result of the calculation in a variable. Let's name this variable result. Pseudocode 5c. Add three numbers. Input number 1, number 2, number 3. Result number 1 plus number 2 plus number 3. Output result end of pseudocode. The new variable result on the left side of the statement will contain the answer from the calculation of the numbers on the right, from the right side of the statement. Calculations can include the left arrow or the equal sign to indicate that the result of a calculation is stored in a variable.
The last part.
Here is yet another set of pseudocode, for example 5, using different keywords to read in the data and to print the result. The keyword end can also be used on its own to denote the end of the statements.
Good.
Pseudocode.
That's it. So note that we have 4 examples here of creating our pseudocode. Now, one thing you should note is that there is no specific pattern that you need to follow. Remember, what you're doing is using English words and phrase to create your pseudocode. But yes, that doesn't mean you can use any random word, but you need to be clear as to what is happening. So in the first example, 5a, this is basically telling you what the program is about. It is adding 3 numbers. So it's saying that input number 1, so basically someone is going to input number 1, number 2, number 3. Then for the processing part, remember it says that you can build your pseudocode from your Ipo chart. So what might be the good practice or the best practice is that before you design your pseudocode, your algorithm, you can create your Ipo chart for you to determine what is your input, what is the process that you want to be carried out, and how do you want that data to be outputted. And from that now, you can create your pseudocode. You know that you are inputting 3 numbers, input number 1, 2, and 3. The processing, you are adding the 3 numbers together, and output now, you are outputting the result of those 3 numbers. And remember, we have to tell the program when to end. So when it finishes output, it ends that program. Now this is another example, 5b, of how you can write your algorithm. If the values are similar, you can put it in the same line. We have the same processing part here, add number 1, 2, and 3. And the same output here, output results of adding those 3 numbers. In the third example, so in the second example here, it's actually just outputting the value, or the result. But in the third example now, when it outputs the result, it's going to put that result into a variable. Remember, the variable is a container. So we can create another container now to hold our variable. So in this case now, with the second example, when it outputted that number, if we want to use that number now, for example, to continue the program or to use it for something else. So say if we want to continue the calculation, after we would have added these 3 numbers, if we wanted to continue the calculation by multiplying it by something or subtracting it from something, then we're going to put it inside of a variable so that we can use it later on if we need to. So in the third example, we have our input here again, but this time here for the processing, we're giving it 2 instructions. We're telling it first on the right hand here to add number 1, 2, and 3. And after you would have finished adding those numbers, put it inside of this variable or this container. Remember, it says at the bottom here, the left arrow or the equal sign is what you will use to indicate that you want to store the result inside of this variable here. And then you can put output variables. Notice the difference between example 2 and 3. Example 2 said output result of number 1, 2, and 3, and so on. That's a bit lengthy. So you can actually shorten it now by putting the result inside of a variable or a container and just saying output that variable. So whatever now is inside of that variable will get outputted. And then you end your pseudocode once again. The last example. Now, remember, for the output, you can state how you want the data to be output. Do you want it to be printed? Do you want to be outputted on the screen? Do you want it to be sent to another program, stored somewhere, whatever the case may be? So in those cases, there are different terms you can use. The term print would refer to, like, if you want to put it on the screen, that can refer to print so that you see the output that you have there. So print result would mean that if you're running the program, it will show up on the screen to give you your result. So in this example, fourth example, we have read number 1, 2, and 3. So notice there's different keywords. read instead of input. So it's basically the same thing. As the person put the values, the program would read the values. Then for the processing part, those three numbers will get added, and the equal sign here again is going to indicate that that result is going to be stored in this variable called result. And then we're going to output by printing that result. Not actually printing, but it could mean that also. But in this case, it would refer to putting the result on the screen.
So that would be like calculator.
Yes, this is an example of a calculator. This is a simple calculator. Any questions on the pseudocode? Yes or no?
Sir, I like the statement read and print. These have to be in all caps.
I I don't. It would be a good way to like differentiate. It might be a good practice to put it in all caps, because it would be a good way for you to differentiate between what is the instruction and basically like what is the variable, what is the instruction, and what is the other parts of the pseudocode. So by putting it into the all caps, you can tell that this is the step, that this is either the inputting step, the processing step, the output, or whatever other step there is in your program.
Okay, sir.
Any other questions on pseudocode before we move on? All right. So next we'll be looking at sequential statements. Devano, are you following so far with the pseudocode? Devano? Seems Devano is not there. So we'll move on to sequential statements and see what that is referring to. So Christoph, can you read for us?
Read from where is it?
Before we start, let me see something. Alright, good, yeah. So sequential statements.
Alright, sequential statements. Sequential statements such as those in example 5 are executed one after the other from the first statement to the last. Let's look again in the Ipo chart from example 2, which finds the average temperature from two values. I already ping boxed it.
Yeah.
For the input is the max temperature and minimum temperature. Processing is calculate, and in brackets they got max temp and minimum temp, so by 2, and the output is the average temperature. The following pseudocode is produced using sequential statements from the information in the Ipo chart. Example 6, find the average temperature. Pseudocode 6a, it says find the average temp. Input is max temp, comma, minimum temp, average temp, equal to the maximum temp, minimum temp, plus the minimum temp, slash 2, and the output is the average temp, and there's the end. First, the value for the maximum temperature is input into the variable max temp. Then the value for the minimum temperature is input into the second variable min temp or min underscore temp. The resulting number from the calculation is placed into the variable average underscore temp. The result stored in average temp is then output.
Good. So sequential statements is, as the word sequential means, it goes one after each other. So what is at step 1 will be carried out before step 2, then step 3, then step 4, and so on. So one after each other. So however you make your statement, that is how it will be carried out, if that's how you design your program. So in our Ipo chart here again, this example, we are creating a program to give us, it's like a basic calculator again, to give us the average temperature of two temperature values. So in this case here, we're looking at a maximum temperature and a minimum temperature. Then to calculate average, we add the 2 and divide it by 2. And then we have an output of an average temperature. So in our example here, this is how our pseudocode would look like. Remember, we put pseudocode colon, and then we have basically the name of the pseudocode or the program that we are creating. I notice there is no space. Remember, we try not to use space. We either use underscore, or we can put the words together with using capital letters for the next word. But it's better to use the underscore to differentiate the two words. Now in this case, for this pseudocode here, the name is find average temperature. So by seeing this name alone, you can tell this is the purpose of this program, to find the average temperature. Now the next part is that it's going to accept input. That's the next step. That's the first step. Accept input. So in this case here, it's going to accept two inputs. We have two variables here, the max underscore temperature, so it's going to accept a value for that variable, and the min or the minimum temperature is going to accept a value for that variable. Now that's the first step, accepting two values for input. The second step now is to calculate the average. So in this case, it's going to notice we have the brackets here again. It's just like in spreadsheets, the brackets are calculated for us. So we're basically saying that that's what we want to calculate for us. So when we're writing a program, we will know that we want to do this part of the calculation for us. So it's going to add the two values together, the max and the minimum temperature, and then it's going to divide it by 2. Always remember BODMAS. Then the third step is when that calculation is finished, it is going to store that value into the variable average temperature. Remember, this is the full part of the step here. And this equal average means that you're putting the value inside of this variable. But in order to get our value first, we need to do the calculation. So the calculation is going to be carried out. Then that value is going to be stored in our variable. And then when that value is inside of our variable, we output that variable. So whatever is inside of average temperature, and then we tell the program to end there. So remember, for sequential statements, they go one after each other, step by step. So let's look at conditional now. Alright, and now we can read 7. Okay. Conditional. Daniel, can you read for us?
Conditional branching. Conditional branching is used when there is a choice between two options. Two types of conditional branching are if-then and if-then-else statement. if-then statements. The if-then statement suggests that one or more statements will only be considered based on a condition or the answer to a question. If the condition is true, then carry out one or more statements, and and if. Sometimes the keyword and if is used to indicate the end of the if-then statement. Any statement below the end if in the pseudocode is therefore part of the general pseudocode and not specific to the if-then statement. Let's use an example. If you wish to output the total of 3 test results, but only if the total mark is greater than 50. In this case, we use the if-then statement. The pseudocode below shows that the 3 marks are each input into a variable. The marks are added and the sum is stored in a variable named total. The if-then statement is then used to check if the total mark is greater than 50. We do not know the value of the 3 marks that will be input. Therefore, if the total mark is greater than 50, then its value is output. The sequence of statements stops here.
Good. So I think, yeah, that's the pseudocode you're looking at. So before we get into that, so note the difference between sequential statements. A sequential statement, it has all of the instructions that needs to be carried out, and it carries it out one after each other. Now, conditional branching has all of its statements also. It has all of its criterias, all of its questions, everything that it wants to do, but it doesn't do all of them one after each other. It doesn't even do all of them because it is looking for a certain condition, and then it will carry out maybe one or two of those instructions depending on how you design your algorithm or your program. So it's just like our spreadsheet where we used the if function to calculate our markup and our discount. We had asked the question, if our cost price is less than maybe 500, then put this percentage. If it is less than 1,000, then put this percentage. So this is similar to that if function. If the test is true, or if the question is true, then carry out this instruction. Either you put this value or you carry out this calculation, whatever you put as the true value for that question. So conditional branching is used when there is a choice between two options. So we have if then and we have if then else. So the if then statement suggests that one or more statements will only be considered based on the condition or the answer to a question. So unless the answer is true or unless the condition is met, then that statement will be carried out. So in this case here, we have if, then, and end if. So the if is the condition, and it's going to be checking to see if that condition is true or false. If it is true, then carry out the statement. How much statement there is, that depends on how you would have designed your algorithm. If it does not meet the condition, if it is not true, then you can say maybe in the end if what to do to end the program because it doesn't have the correct result, or tell the person that, look, error, you did not enter the correct value, something like that. So just remember, for the if, it's just like spreadsheet. It looks for a condition and then gives you your result based on that condition, or carries out something based on that condition. All right. Let's see. Gurindra, can you read for us? Start back from the example.
Um,
Yeah. Hold on.
I guess.
Just take your time and go through it slow.
Starting from let us use an example.
Yeah.
Let's use, let's use an example. You wish to output the total of three results, but only if the total mark is greater than 50. In this case, use the if then statement. The pseudocode below shows that the three marks are each put into a variable. The marks are added and the sum is stored in a variable, total. The event statement is then used to check the total mark equals than 50. We do not know the value of the three marks that will be input. Therefore, if the total mark is greater than 50, then its value is output. The sequence of statements solved below.
Read example 5, example 7.
Example 7. Print the sum of three numbers if their total is greater than 50. To the code 7. Add three numbers. Read number 1, number 2, number 3. Total is equal to number 1 plus number 2 plus number 3. If total is more than 50, then print total. And this ends.
Good. You can stop there. So, in this example here, we are looking at the total if it is greater than 50. Remember, we're looking at the total or the output if it is greater than 50. So that's our test. That's our question. Is total greater than 50? So what the program is doing is accepting three values. And these three values now, these three marks, they're going to be inputted into three variables. They're going to be added, and that value is going to be stored in another variable called total. And if that total is greater than 50, then it will become the output. So in our example here, our pseudocode, we're adding three numbers together, and we're going to print the output if it is greater than 50. So the first step is to read the numbers. Number 1, number 2, number 3. So when that person inputs the numbers, we're going to read that three numbers. Then the next step is to add those three numbers together. Number 1, 2, and 3. And when those numbers are added, we're going to store those numbers into another variable. That variable is going to be called total. Now, this is where the condition comes into play. This is where the sequence ends and the condition comes into play. We're going to have a test now. Is the total, this output result here, this variable, if the total is greater than 50, it's going to run this test. Is total greater than 50, then print the total. The end if can indicate if the program, if the if statement, that is if statement has ended here, or you can maybe say that what the person can do, or whatever may happen in the situation of it not being greater than 50, and then you end your program. But just focus on this part here for now. We are running a test to see if total is greater than 50. If that is true, we're going to print the output. If it is not, we're going to print total as output. But if it is not true, then the program will end with basically no output because we didn't specify anything else as the output. Isaiah, can you continue?
First,
You started from the condition. You don't want to? And why do you not want to, Isaiah? So you're scared you won't sound good enough for the girls today. Okay, Jada, let's hear you.
Okay, then the condition or question that is the total mark greater than 50? If it is, then the condition is true. The mark is indeed greater than 50. Next statement in the sequence indicates to output the total mark. That is, if you use 20, 25, and 10 as the three marks is to the input, then the total mark of 20 plus 25 plus 10 equals 55. Since 55 is greater than 50, it is expected that the value 55 will be the output. Can you go down, please? If then statement does not consider if the total mark is less than or equal to 50. That's all. As there are no statements in the code that instruct the result to be output. If the total mark is less than or equal to 50, then condition will be false. The next statement, then print total, in the sequence is skipped, and the piece of code reaches the end without printing anything. The keyword in this example are read, if, then, print, and if, and end. The variables are number 1, number 2, number 3, and total. That's a lot. Okay.
Alright, let me have another reader. Narish, you can continue.
The general format.
Yes.
The general format of its statement is if condition is true, then T statements, and if if condition is true, execute T statements. If is a keyword. Condition is a Boolean
Boolean.
Boolean expression, which means its value is either true or false. T statements are one or more statements that are included only if the result of the condition is true. And if tells the computer that if then statement finish here. Statement finish here. If the condition is false, skip T statements. That is, do not execute them.
Consider.
Consider the following example to find out if a student is younger than 13 years old. If so, then we want to output the statement. Student is not a teenager. For this, we need to use if then statement.
Alright. So I guess that's for example 8. So remember, as I mentioned, this is our pseudocode. We're accepting 3 numbers, and the test or the if function is if it is greater than, if those 3 numbers are greater than 50, then we're gonna print total, and then we're telling it end if to end there. That's the end of the if program. So this is the format for your if function. We have 3 parts. We have the if, we have the then, and we have the end if. So the if is the condition. We're going to test something, we're going to ask a question, and if that condition or that test is true, then we're going to have this T statement or this true statement. So if the condition is true, then execute or carry out the true statement. So remember, the statement is the instruction. It's what you're telling it to, what should happen. So unless this condition is true, only then will this true statement be carried out. If is a keyword. So condition is a Boolean expression if it is true or false. So a Boolean expression basically means that there's only 2 values. If it is on or off, if it is true or false, if it's 1 or 2, it could only be 1 or 2 values. So it's basically a test, and in our case, we're going to test something to see if it is true or false. So is something less than something? Is it greater than? Is it equal to? Remember all the time.
Sir, why don't how you teaching me this thing now, right? Why you don't go into and write the actual code, right? And show you how this thing this works, sir.
Remember, this is not the code. This is the pseudocode, is not the actual code. So when we get to that, then we'll look at that. But these are like the steps that you need to take before you write the code. So these are like the English language part. This is like the paragraph that you need to write before you get into the actual coding, so that you understand what you're going to do before you get into the coding. So this is not the coding as yet. So yeah, as I mentioned, the condition is a Boolean expression, which means that it's either true or it's either false. So it has 2 states. If it's either true or if it's false. So that's what we're going to be testing for. Now, if it is true, then carry out the true statement or the T statement. The T statement are 1 or more statements that are included if the result is true. So it don't have to be just 1. We can carry out different statements or different calculations, different processing if the test was true. And we put end if to tell that program or the computer that that's the end of that if then statement. So if the condition is false now, then the true statement is going to be skipped. So basically no statement or instruction was carried out and nothing will be executed. That's a lot of examples of pseudocode. So we're gonna pause at that example for today. So remember, as I mentioned before, we are looking at, for this topic here, we are looking at creating a program. So before we get into creating a program, there are a few steps that we need to follow in order for us to do the actual coding for our program, so that we understand what we're going about doing. The first step is to find the problem. What problem do we want to solve? Remember, I gave the example, we don't know how to create a sandwich. So that's our problem. We created a program to solve it. Then the next step is for you to create an algorithm. And the algorithm is English steps that you can understand to carry out the instructions to create the sandwich. So you have to understand before you create the program what steps needs to be carried out. Go to the store, buy bread, bring bread home, put bread on table, take out bread. You need to understand all of that before you go about doing your coding. So that is where the algorithm phase comes in. That is where you go about creating your precise steps. And one example, as well, the two examples of the algorithm is your flow chart and your pseudocode. So that's what we're looking at today. Your pseudocode is English steps that you're going to take to create English steps of your program basically. So this here is basically your program, but it's just that it's in English words for you to understand. And this is what you need to do first before you create your program, so that you know when you go. Remember the programming language. You would not fully understand it because it's using different words and text and syntax and so on. So you won't fully understand it as you put different parameters and so on. So that is why it's important for you to understand the algorithm, which is the English version, so that you know what you're doing inside of the programming part. So this is basically your second step when it comes to creating your program. So, but before that, you can create your Ipo chart, which is basically stating what you're gonna accept as input, the bread, the peanut butter, the knife, the jelly, and so on. Then the processing, how you're gonna put all that together, and the output. You want to output the sandwich. So by understanding what is the three parts, you will be able to create your pseudocode, which is the English version, and from that now you will be able to write up your programming code to create your program. And that is where we head into the implementation phase, actually converting the algorithm now into your program. And these languages here are what we'll be using. Well, not all of them, depending on which one we choose, but it's either going to be Pascal or Visual Basic. We're going to have to decide upon which one we're going to use.
Sure. So like, giving us a quick example, right? Like, what would I create this program to do, sir?
For the SBA,
Yeah, yeah.
I was thinking that maybe for what we can do is like how we have the invoice inside of your spreadsheet, do something similar. Like let you you can input the item name, you input the quantity, you can input the customer first name and last name as input. So if you look at the IPO chart, that could be your input. Customer name, the item that the customer wants, the quantity. Because remember, that's all they can specify. So that can be your input. And the processing now could be you calculating the cost price, not the cost price, the you're gonna calculate what's the amount for that item, what the VAT is gonna be for that item, what the discount is gonna be, what the total cost is gonna be, things like that. That's all gonna be your processing, and then you basically output the results for your discount, output the result for VAT, output the result for your payment, output the result for your change, something like that.
Okay, sir. All right. So this will not be like the only thing we have to do.
Yeah, that should be. But remember, it's not just the SB is not just about designing the program. they want to see also all of these IPO chart, the algorithm, the pseudocode, the flow chart. They want to see all of that also.
All right, sir.
Because remember, you have to do these steps before you come up with
We
the
get the
program.
program. Yeah, yeah. All right, yeah, thanks.
Mhm. Any other questions? All right, so we can stop here for today. Next week, remember, we're continuing from example 8 and we're going to look at the rest of pseudocodes. So if you guys don't have any other questions, you are free to leave. Enjoy the rest of your day.